So these ones are just written versions of the ones we've done before. It's just understanding what the question is asking. So if we go through it and mark out the important bits, so a transformer is designed with 20 turns of wire in the primary coil. So we know turns is N, represented by N. And this is saying in the primary coil. So we, drawing it out, we know that number of turns in the primary, it says there's 20. And 2,000 turns, again, is N in the secondary. 2,000 turns in the secondary. So 20 in the primary, 2,000 in the secondary. If the induced voltage in the secondary coil, so voltage Vs, secondary coil, is 4,000, calculate the primary voltage. So just like with the other ones, we need to create that primary voltage. So just like all the other examples, if we map it out, primary, secondary, we have a value on either side of the transformer for the number of turns. So N, the primary is 20, secondary is 2,000, large by small, 2,000 divided by 20. 100. So we know the ratio is 1 to 100. Because 20 goes into 2,000 100 times. Ratios 1 to 100. We don't know VP, but we know VS. So that's 4,000. We know from the ratio that anything on the right-hand side is 400 times greater left-hand side. So we need to reduce the 4,000 secondary voltage by 100, which gives us 40. So our primary voltage is 40. So we can see that everything on the right-hand side is 100 times bigger than on the left. Number 7. So it says a step-down transformer changes the voltage of a signal from 360 volts down to 18. So we're stepping down. So your primary will be a larger one. Your secondary will be a smaller. So again, map it out. Primary voltage primary 360, and it's going down to 18 volts on your secondary. So then the next part of it, so we've covered them two. If the transformer had 200 turns in the primary coil, calculate the number of turns in the secondary coil. So N is the number of turns, primary coil. So we know that MP is 200. So we're missing number of turns secondary, but we have a value for each of the voltages. So map it out. Voltage primary 360. voltage secondary, 18. Calculate the ratio. 360 divided by 18. 20. So 360 is 20 times larger than 18. We know that the number of turns is 200 on the primary and 200. So we know that anything on the primary side is 20 times bigger than on the secondary. So we take that 200, divide it by 20, which is 10. So we know that the secondary side is 10.